Hi guys, this is a revision video for the GCSE Physics Unit 2 on AQA. This video is about speed, momentum and forces in general, also called mechanics. The first thing you need to know is about speed, and you just need to know the basics. First, that speed equals distance divided by time. Speed is measured in meters per second, distance is measured in meters, and time measured in seconds. And you need to be able to distinguish between speed and velocity. So first is speed. These two cars are travelling at 70 miles per hour. One's going that way, and one's going this way. They're both going at the same speed because they're travelling at the same rate. Velocity, on the other hand, is measured in speed and also direction. So if two cars are going at the same speed, but one's going north and one's going south, then you've got different velocities, and you write it as 70 miles per hour north or northeast or southeast, etc. You also need to be able to work, if you're doing height here, this height here in specific, you need to work with speed, distance time graphs and velocity time graphs. A distance time graph looks like this, more or less. As you can see, it's got a straight line, and the straight line represents a steady speed. When it's got a straight line, it represents that it's stationary. And if it's got a line that varies in steepness, then that means it's not going at constant. That means it's not going at constant speed. Its speed's changing. The gradient of the velocity of the distance time graph is its speed. So if you're doing height here, you'll need to know how to calculate the gradient, and the gradient is just y divided by x. The velocity time graph, however, is very different. Instead of the gradient being speed, the gradient symbolises acceleration. So if it's got a straight line like here, then that means it's going at constant acceleration. If it's got a straight, if this line is horizontal, then that means it's got a constant velocity. It does not mean it's stationary. The object is only stationary if the line is down at the bottom here. That's when the object's stationary. Stationary means still, for those who don't read. And if it's got a straight line going down, that means it's decelerating, which is the opposite of accelerating. Acceleration, by the way, is velocity divided by time taken. Also, if you're doing height here, you need to be able to work out the distance travelled. The distance travelled for this is the area of this space under the graph. So you'll need to find out the area of that triangle there using the values that you're given on the velocity and the time axis. This huge rectangle in the middle and this triangle going down, and that will tell you the area, and the area is the distance that it's travelled. Next, you need to do resultant force. A very simple example of resultant force is this one here. So you've got a picture of a car, and the driver is at the force forward put by the driver is 10 newtons, and the force backwards by the drag force is 8 newtons. The resultant force is 10 take 8. 10 going this way, 8 going that way. It's 10 take 8, which gives us an acceleration of 2. So that means the car is accelerating. On the other side, the car is 10 newtons this way and 10 newtons that way. 10 take 10 equals 0. That means it's not accelerating, but that means it's travelling at a constant velocity. It's travelling at the same rate. It does not mean the object is still. If it was 10 take 12, which would give you -2, that means it's decelerating by a rate of -2. Next, you'll need to know about weight and gravity. You need to know the difference between mass and weight. In fact, when people tell you their weight, they're actually telling you their mass. Weight is the force acting on you. Weight is mass. Weight is mass times gravitational field strength, which on Earth is 10 newtons per kilogram. And weight is force. Mass, is how much of you there is. The mass is what people always talk about when they tell you what they weigh, and the weight is what you need to know usually physics. You need to be able to talk about different forces acting on different objects. So here's a car driving. Going this way, pushing the car back, is drag force. Going this way, pulling the car forward, is the driving force applied by the driver. Pulling down is the weight, and going across is the friction. On the other side, there's a parachutist, and you can see there's air resistance which is pulling the parachutist up, and gravity and weight are both pulling it down. We need to talk about falling objects too. So there are three main steps to when an object is falling, which you'll usually be asked about a parachutist in the exam. Step 1 is it accelerates. As it falls out of the plane, it gains speed by accelerating, and the drag force, with the air resistance and drag force, is much less than the weight. Then air resistance occurs as the parachutist opens its parachute. The air resistance is the drag force, and the air resistance gradually increases until it reaches the same as the force acting down, which is pulling the parachutist. Then it reaches a terminal velocity, and the parachutist just travels at constant speed as it falls to the ground. You need to talk about stopping distance when talking about cars. Stopping distance equals thinking distance plus braking distance, and you need to talk about what factors affect different things. So what affects the braking distance is weather conditions on the road. So if the road's icy or it's been raining, then the car's going to take longer to brake. Worn brakes and tyres, if the car's basically in bad condition, that could have effects on how long it takes the car to stop. And a heavier car, not necessarily how big the car is, but if there's lots of people, lots of luggage in it, then that's going to slow the car down. Also, you need to talk about thinking distance. Factors that affect the driver's thinking are alcohol, drugs, tiredness, and illness. The next thing is talking about energy, which you need to talk about work done, workforce and distance. Work done equals force times distance. The work done is measured in joules, the force is measured in newtons, and the distance is measured in meters. The work done is a way of transferring energy. So here you've got a crane which is lifting an object 10 kilograms up a distance of 300 meters. The work done is 10 times 300 equals 3,000 joules. We need to talk about potential energy and kinetic energy. And here I've listed the different types of potential energy you need to know. So, elastic potential, which is if the object is squashed or stretched, or if the shape is changing, that's elastic potential energy. Gravitational potential energy is raised against gravity, so the higher an object is, the more its gravitational potential energy is, because it's working against gravity. And then kinetic energy is the big one, which is basically how much an object is moved compared to its weight. Momentum is the next thing you need to know, which is the most complicated on this topic. Momentum is basically how hard it is to stop or turn an object in its path. The correct definition of it is the tendency to move in the same direction. Here I've got a picture of a really huge fat man who weighs about 1,000 kilograms and is moving at a speed of 7 meters per second. So the fat man is moving really fast and is travelling really fast, and it's got huge weight. That means it's got high momentum because it's going to be much harder to stop him than this little mouse who is moving at about 0.5 meters per second and weighs about 1/2 kilogram. That means it's got a much lower momentum because it would be much easier to slow down that mouse. So heavy and fast means the object has a high momentum, and light and slow means the object has low momentum. The conservation of momentum is keeping momentum the same. So during a collision and explosion, as long as there are no external forces acting on the collision, the momentum will be the same before and after the collision. In cars, you have certain factors like seatbelts. The seatbelts stretch to increase the time for the body momentum to reach zero. You also have airbags, which increase the time for the head momentum to reach zero. For the head and the body work at different rates. And then if you're doing height here, this one will be important for you. Kinetic energy is worked out by 1/2 times mass times the speed square, and kinetic energy is affected by mass and its speed. Momentum can be used to calculate a force, and the force needed to change the momentum is worked out by the change in momentum in kilograms per kilogram meters per second divided by the time taken. I hope you found that quite useful. I only did that because it helped me with my revision. If you need any extra help on that part of it, then use GCSE Bite-Size or any textbooks. I'll be doing one later about static electricity, mains electricity, current electricity and radioactivity.